Bismillahirrahmanirrahim. Today I'm gonna explain you crystal structures from close packing of anions. So for metals, all of us know that we use atoms for discussing the crystal structure. But for ceramics, we are here discussing the anions and cations. Anions actually they are set according to the stacking pattern, and then in the interstitial positions there are fitted cations. They can reside there in the interstitial positions. So this is basically the crystal structure close packing form of ceramics. So one thing about interstitial position, I must tell you, they can be tetrahedral or octahedral positions. Tetrahedral is the one in which ion would be arranged in three ions would be in one plane, and the fourth one would be above them, and the central one would be forming four kind of bonds that comes in tetrahedral. And octahedral case includes the pattern in which the central central cation is having the bonds 6. It's linked with 6 other anions, so it would be octahedral structure. Octahedral position, you might say that it's octahedral, in which there are 6 links between the central cation and the surrounding anion. So the coordination number of cation in tetrahedral would be 4, and in octahedral would be 6. Now I must tell you about for each anion, 1 octahedral and 2 tetrahedral position exist in a ceramic crystal. For one anion, there are always 1 octahedral and 2 tetrahedral positions in ceramic close packing structure. Okay, then I will tell you about the factors which are affecting crystal structures of ceramics. They are basically the stacking, in which the ions would be arranged, that it could be FCC or HCP, and the manner in which interstitial sites are filled. So the stacking can be FCC or HCP, and the manner in which the interstitial sites are filled with cations. These would be the two factors which are affecting the ceramic crystal structure, or in which the ceramic crystal structure depends. Now in case of NaCl, you can see that it's a kind of stacking in which the ions are arranged in ABC form. So it would be FCC, and the manner in which interstitial sites are filled with cation. What would be the manner? I mean to say, from manner, I am talking about the positions that I already discussed, octahedral or tetrahedral. So in case of NaCl, as it is FCC, you might observed in the structure that each cation would be surrounded by 6 anions, and similarly each anion is surrounded by 6 cations. So coordination number would be N6, and the cations would be in octahedral position. Okay, now density computation about ceramics. We have already discussed about density computation for metals or for elements, but now we are talking about ceramics, so it would be a little bit different. So we are finding the density with this formula, where n prime denoting the number of ions in the structure, and AC, the sum of AC, is representing the atomic weight of cations and atomic weight of anions. The sum of atomic weight of cations and sum of atomic weight of anion, where Vc is the volume of unit cell, and the Na is number of Avogadros, which is Avogadro number it is the value of this is 6.023 exponent 23. So in this